So one of these should be really, really obvious, right? I know that W has to be the same as 100, right? Because these chords are the same, so these intercepted arcs have to be the same. So I'm going to put equals 100 degrees for my W, and then I'm going to box that answer. All right, now I can't find X and Y if I have two missing variables and the whole thing has to equal 360. So we're going to ignore the triangle, the circle for the time being, and we're going to just talk about the triangle. All right, because this is a radius, and because this is a radius, and all radii in the same circle are congruent, I'm going to put triple tick marks on both of those radii. Now that is an isosceles triangle. And if you remember about isosceles triangles, these two angles have to also be the same. So this is going to be 35 degrees as well. All right, and if I subtract 35 and 35 from 180 and use the third angle theorem, I'm going to get 110 for that missing angle. Okay, now that's important because if you remember from 2 class periods ago, this central angle always has to match its intercepted arc. Okay, so there we go, and we have our Y. Okay, now if I know that this is 100, this is 110, and that's 100, I can find out what X is by subtracting them all from 360, the total amount in a circle. So 360 minus 100 minus 110 minus 100 ends up getting me 50. All right, and 50 degrees is going to be my X. All right. Now, we just talked about this. On the front side, we talked about how tangents form 90-degree angles with a radii in a given circle, which means we can use a squared plus b squared equals c squared to our heart's content, no matter what, right? We can use this to find missing side lengths. Now, you might be wondering where that's going to come into play, but if I take the center and I draw a line and I connect it to the end, that looks like a right triangle to me, right? And if I say that this side is 3 and this side's 4, I can use a squared plus b squared to find this side that's going to be c squared, and I'd find out that it's going to be 5, right? So I'm going to use the fact that there are right angles all the time. You can see it in this next diagram, which isn't even about right angles, right? That is about the other important theorem. If you have two tangents, right? Let's look at the first one. The first one starts at A and it has a point of tangency at D. The other one starts at A and has a point of tangency at B, all right? But if two tangents, right, going over here, meet at the same external point, and in this example, our external point's A, then those tangents are going to be congruent. All right, that's why we have a tick mark here and a tick mark here. All right, so every single time you see a tangent problem, I want you to add right angles if you can, add tick marks if you can. It's not going to be used in every problem, but I want you to see big picture and at least you have all the information possible. All right, so this one right here, the difference about this problem versus a different tangent problem where I say it is tangent to the circle, okay, is that this one is a question. When I say, is the segment KJ tangent to circle P at J, you have to tell me whether or not a squared plus b squared equals c squared still works. Let's write that down, okay? You must show that a squared plus b squared equals c squared still works, okay? Now, this is not a new concept. We've done this before to see if a triangle is a right triangle or obtuse or acute, all right? So it's the same old, all right? We're going to do that by taking A, which is going to be 9 in this example, 9 squared plus 6 squared equals c squared, right? Don't be deceived. You have to add these two sides, and the c is going to be 10. All right, if I do 9 squared plus 6 squared in my calculator, I get 117. And I know that 117 is not going to be equal to 10 squared, which is 100, right? So anytime I come up with something like this, I have to make a conclusion. I'm going to say therefore, the 3 dots mean therefore, KJ, segment KJ, is not tangent to circle P at J. All right, and that's going to be my answer. Now, most of the time, I'm not going to ask you if it's tangent or not. I will say it is tangent. Like in our next example, it says these lines are tangent. All right, and as soon as you see something is tangent, then you can add those 2 theorems that we just talked about. All right, so the very first thing that I'm going to add is I'm going to, in some way, I'm going to figure out how to add my 90 degrees. Okay, so I'm going to make a point of tangency at G, and I'm going to drop a radius down. Okay, that's going to be a 90 degree. All right, I'm going to make a point of tangency at K, drop a radius over. That's going to be a 90 degrees as well. Now, that doesn't really help me because it doesn't tell me anything about angles. But the second thing that I can add is the tick marks. And that does help me, right? And now we're going to be back to another algebra problem where I take this side and set it equal to that side. So 5a minus 32 equals 4 plus 2a. I'm going to solve for a by moving the 2a to the other side. And I get 3a equals, okay, add 32, 36. And I get a equals 12. Okay, not my final answer because I'm looking for hg. So I have to take the 12 and I have to plug it back in. So hg is going to equal 4 plus 2 times 12. Okay, 2 times 12 is 24. I add 4 to it, and I get 28 again. All right? Last 2 questions. In this example, B and C are points of tangency. Again, anytime I see that word tangent with certainty, I'm always going to be adding 90-degree angles. So I can add a little 90 right there, and I can add a little 90 right here, and I can add my tick marks. Okay, by default, that's what I should be adding. Now, the tick marks don't help me at all because do I have anything known about these side lengths? No. So I'm just going to ignore the tick marks. But the angles are really going to help me. All right? Now, a lot of people were not remembering this today, but that looks like a kite. That's a quadrilateral. All quadrilaterals have 360 degrees. All right? So I'm going to find that missing angle by subtracting 90, 135, and 90. And then when I do all that, I end up with 45 degrees for my x value. All right? A lot of people couldn't get that on their own. That's why you need to make sure that you write down all the pieces of information that you could conclude for every problem. Okay, last one. And you might think that this one doesn't look like a tangent problem at all, but it does. If I take, a piece of paper and I cover up part of the problem, like that, right? To me, that looks like a tangent, and that looks like a tangent. It looks like they start at F, and they have a point of tangency at E and at G, all right? And the same is true if I cover up, like those ones. Those are 2 little tangents, blah, 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 okay? And same with these ones right here. So we have a bunch of tangents of all different sizes, except you know that if they share the same common endpoint, they have to be the same. So let's put a tick mark on this little guy and this little guy. They have to be the same. These 2 have to be the same. And then these 2 have to be the same, right? Now, if that's 3, by default, this one's 3. And if this whole thing is 8, and that's 3 of the 8, this has to be 5, which makes this one 5. And if that is 13, and we have 5 of it right there, this last one's